Today we're going to talk about the squeeze theorem. The squeeze theorem says that if you have three functions such that this inequality is true on some interval, and that if the limit of h of x is equal to the limit of g of x, then something interesting happens with f. So let's draw this here. We've got C, I'm going to put L, and let's do h of x in pink. So h of x is going to have a limit of L. G of x must be greater than h, but share a limit. And now watch what happens when we draw in f of x having to be between h and g. F of x will have to also share the same limit. So if this is true, then the limit as x approaches c of f of x is also equal to L. Now the squeeze theorem can help us evaluate limits. Like this one, for example. Our algebra that we know so far fails us here. Substituting will give us a denominator of 0. There's nothing to factor and cancel, and there's nothing to rationalize. So we have to go about this a different way. So what we're going to do is start off with an inequality. So first I'm going to take this right triangle here, and we're going to say this is a unit circle, which means that this dimension from here to here is equal to 1. So this point is 1, 0. This point here is some x and y so we'll use trig form of that point, which will be cos and sine. But then there's labeling this point up here. Well, we know it's 1 comma something, and that something is actually tangent. And the reason is, here's our theta. We know that tan theta is y over x. Well, for this coordinate, we know that x is equal to 1, which means that tan theta is equal to y. So tan theta is our y for that coordinate. So now let's begin setting up an inequality. We're going to start with the area of this big triangle right here. So the area of that triangle we know is half of the base times the height. So half of the base, half times 1 is 1/2, times the height, and this height is tangent. So we end up with the area of that triangle being 1/2 times 1 times tangent. Now that area is going to be greater than or equal to the area of this sector, this circular sector, this little slice right here. Now the area of a circular sector is, that's an equal, so area equals theta r squared over 2. So in this case we don't know what theta is, but we know that the radius is equal to 1. So the area of our little sector here becomes theta over 2. And the area of that sector must be larger than the area of this little triangle right in here. And that's 1/2 base times height, so 1/2 of 1 times the height, which is sine. So we end up with sine over 2. Now what we're going to do is multiply everybody here by 2 over sine theta. So here we're going to have 1. In the middle, the 2's will cancel. We'll have theta over sine theta. And over here, the 2's will cancel again, but we'll have tan over sine. So tangent divided by sine is actually 1 over cosine. So on the left here, we'll have 1 over cosine. Our next step, what we'll do is take the reciprocal of each of these. The reciprocal of 1 over cos is cos. The reciprocal of sine over theta is, theta over sine is sine over theta, and then the reciprocal of 1 is just 1. But since we took the reciprocal, we have to change our signs here to less than signs. Now notice we have this inequality like we saw with the squeeze theorem. We've got one function squeezed between 2 other functions. And we know that the limit as theta approaches 0 of cosine is the cosine of 0, which is 1. And we also know that when theta approaches 0 of this function, which is 1, that limit would also be equal to 1. So by the squeeze theorem, we can say that the limit as theta approaches 0 of our middle function of sine theta over theta is also equal to 1.